Good morning, students. In the last class we have completed till exercise 14e. Now in this class we'll continue with exercise 14b. Okay, but before we start exercise 14b, we need to study more about quadrilaterals, some special types of quadrilaterals. Okay, now when we start learning about polygons, okay, so what is a polygon? A polygon is a plane closed figure bounded by at least 3 line segments, and the smallest polygon that we've learned was a triangle where the number of sides is 3. Now when I increase the number of sides as 4, now the polygon is known as quadrilaterals. So therefore, what is a quadrilateral? In a very simple way, if you go to the definition in your book, a closed plane figure bounded by exactly 4 line segments is called a quadrilateral. So according to definition, it should be a plane closed figure bounded by 4 line segments. So there are many plane closed figure bounded by 4 line segments, isn't it? So therefore, in this chapter, we will be coming across this type of 4-sided figure, like trapezium is one of the quadrilateral, parallelogram, quadrilateral, a rectangle, it is a quadrilateral 4-sided figure, square is also a 4-sided figure, and then rhombus also a 4-sided figure. Okay, so as you go in your book in page number 169, then here you'll see one heading, spatial kinds of quadrilateral. I want you all to go through page number 169 and then page number 170, page number 171, 172 and page number 173 as well, and do learn all the theorems, theorem 11, theorem 12, 13, 14, 15, 16, 17 and 18, just to understand the statement of the theorem, because this is very, very important before we start exercise 14b. Now, spatial types of quadrilateral. Number 1, trapezium. Go through the definition of trapezium and its figure, its properties given here. Parallelogram, its definition, okay, its properties, a figure given out here, right? Rectangle, rectangle we already know, we've done rectangle. Rhombus is also a spatial type of quadrilateral, okay. Square, it is a quadrilateral 4-sided figure where all sides are equal, okay, and also the theorem given out here, okay, just the statements. It's very, very, very easy. Okay, so now we start exercise 14b. Okay, let's start with exercise 14b, question number 2. Now the figure and the question is given out here. Please go to the question. In the given figure below, AM bisect angle A, DM bisect angle D of a parallelogram ABCD. Okay, so ABCD is a parallelogram given to us. Now parallelogram means it's a 4-sided figure. It's one of the quadrilateral. Its properties are the opposite sides are equal and parallel. Okay, the opposite sides are equal and parallel. Now, what we are to prove out here is we have to prove that AMD, angle AMD, this angle we have to prove it as 90 degree. And the conditions given out here is DM bisect angle D. Bisect means DM. Yeah, this DM is dividing this angle equally. This angle and this angle, they are equal. Similarly, AM also bisect angle A. This angle and this angle, they are what? Equal. Okay, now I'm assuming this angle as X, this angle as X as well, because they are equal. Now I'm assuming this angle as Y and this angle as Y. I hope you're clear with this. Okay, X, X, Y, Y. Now what we know is that, AB is parallel with DC. Let's write down. We know AB parallel with DC. The reason we know this, because since ABCD is a parallelogram, and once they are parallelogram, the opposite sides are always parallel. So therefore, if these two are parallel, then AD is a transversal. This implies that AD is the transversal. It is the transversal. The moment AD is a transversal, then angle A plus angle D will be equals to 180 degree. So therefore, this implies that angle A plus angle D is equals to 180 degree. Sum of co-interior angles. Co-interior angle is always equals to 180 degree in case of parallel lines. Now angle A is X plus X and angle D is Y plus Y, which is equals to 180 degree. So therefore, if you do it, it is 2x plus 2y is equals to 180 degree. So therefore, this will give you 2 common. X plus y is equals to 180 80 degree. So therefore angle x plus angle y is equals to 90 degree. So this is what we have got from the given condition in the figure. X plus y equals to 90 degree. Okay, so therefore x plus y, if I see in triangle AMD, x plus y equals to 90 degrees. So if this angle has to be 90, so finally I'll write down in triangle AMD, angle x plus angle y plus angle AMD, sum of three angles of this triangle should be equals to 180 degree, isn't it? So therefore what we have got from equation 1, x plus y equals to 90. So 90 degree plus angle AMD is equals to 180 degree. So therefore angle AMD is equals to 180 minus 90, which is equals to angle AMD is equals to 90 degree. So hence we have proved. Okay, now see, calculations are very easy, understanding also very, but the key points out here will be like this. Yes, AB is parallel to DC. We should know this AB is parallel to DC because ABCD is a parallelogram, and once they are parallelogram, you know the AD is a transversal. If it is transversal, the co-interior angles are equal, then it's very easy for us to understand. Okay. Okay, now this next question I am taking is question number 3. So in question number 3, given to us ABCDE, this is a pentagon, 1, 2, 3, 4, 5, it's a pentagon is given to us in such a way that angle A is 102 degree. Okay, AE is parallel to BC, you can see in the figure, parallel, and AB, CD and DE, they are what? Equal sides. Now the question is asking us to find angle AEC. I need to find angle AEC. So this angle I need to find. Okay. Now what we'll do out here is we'll do a small construction out here, and the construction is write down construction join E and C. So the first step I am doing is join E and C. Let's join it. So if I join it, then I'll be getting a quadrilateral, a four-sided figure. Then ABCE. Okay, ABCE is a quadrilateral. It is a quadrilateral. Another thing I know is that AE is parallel with what? BC. AE parallel with BC. So in the same way, angle A plus angle B has to be equals to 180 degree. Angle A plus angle B is equals to 180 degree. Let me complete and I will show you. Okay. Okay. So therefore, AE is parallel to BC. Angle A plus angle B is 180. Put the value for angle A. So I get the value for angle B out here, which is 78 degree. Now come back in the figure. This angle is 102 and this angle is 78. So sum is equal to 180 degree. Okay. Now if I look at this figure ABEC, this is a quadrilateral, and this quadrilateral is nothing but it is again here parallelogram. Okay. So if it is a parallelogram, then we can apply the property of parallelogram out here. Parallelogram, in a parallelogram what happens is that the opposite angles are always equal. So this angle is 102, it has to be 102. This angle is 78, it has to be 78. And one thing I know is that in parallelogram the opposite sides are always equal. So this angle, this side should be equal to this side, as well as this side should be equal to this side. So hence as well out here AB should be equals to EC. We need to write out here. Okay. So as ABCE is a parallelogram, one thing I know is that AB is always equals to EC. Okay, so figure AB is always equals to EC, and I know that AB is equals to CD is equals to ED, and also AB equals to EC. So therefore CED is an equilateral triangle. So therefore ECD, triangle ECD is a equilateral triangle. So hence it is an equilateral triangle. Then this angle has to be 60 degree, this angle has to be 60 degree, and this angle has to be 60 degree. So I'm keeping it as 60, 60, and then 60 as well. So therefore my answer is done. I was asked to find AE isn't it? AEC. Oh, number 1 was angle AEC. So angle AEC 68 degree from the 78 degree from the figure. Okay, and the next one is BCD. BCD. Okay. Next one we need to find is angle BCD. Angle BCD is 102 plus 60. So I think so the answer is angle BCD is 162 degree. So these are the two answers that we need to find. Okay, BCD. So this is your question number 3. Number 2 and number 3. Now we move to question number 4. Okay. Alright, next question I'm taking is question number 4. Now question number 4 is a bit lengthy question, okay, so we'll do part by part. Okay, so let's read the question first. ABCD is a square. So I've taken ABCD is a square. ABCD, if it is a square, all the sides are equal. The diagonal bisect each other at 90 degree. The corner angles are 90 degree as well. So these things we know. Okay, diagonals meet at O. P is a point on BC such that OB equals to BP. Okay, diagonals meet at O. So let's draw the diagonals. So diagonals means a straight line which touches the opposite vertices. Okay, and this diagonals meet at O. Okay, now we know that all the corner angles are 90 degree, 90 degree. Okay, so this has to be 45, 45, 45, 45, 45, 45, 45, 45, and diagonals meet at 90 degree. So this is 90, this angle is 90, and then so on. Okay, now there's a point P on BC. There's a point P on BC. I'm keeping a point P on BC. Now this point is BC is on BC in such a way that OB is equals to PB. So this OB is equals to PB. Huh? This is a given thing to us. We need to show that angle POC. So POC. So construction, the first construction I'm taking out here is join O and P. Join OP. So this OP. Okay, I've joined. Now I have to prove that angle POC. So to prove angle POC is equals to 22.5. So that's 22.5 I'm keeping 22.5 degree I have to prove. Okay, so this is the first question that I have to do, number 1. Now how we'll start? Now we'll start with, the one thing is clear out here, this angle is 45 and this angle is also 45 degree. Okay, PBO from the figure, angle PBO is equals to 45 degree. So everyone knows this. This is true in case of a square. Another important thing I know is this angle and this angle this side and this side are equal. So once these two sides are equal, the opposite angle is always equal. Okay, so I'm keeping it as X and keeping it as X again. So in triangle, in which triangle? In triangle OPB, X plus 45 degree is equals to 180 degree. So therefore 2x is equals to 135 degree. So if you divide it, then you will be getting 67.5. So therefore this is how much? 67.5. Okay, so this is a 67.5. 67.5. On a 67.5, then I know this angle, this whole angle is how much? 90 degrees. So if you subtract 67.5 from 90, then you get POC. Okay, now write down as angle BOC. BO, I don't know whether you people can see it or not. BOC. BOC is 90 degree. Huh? This is 90 degree. But in our BOC, we have got BOP as angle BOP plus it is angle POC. Isn't it? Angle BOC is sum of BOP plus POC. Please relate from the figure. Angle BOP we have got 67.5 and POC we need to prove, which is 90 degree. If you subtract it, you will be getting easily 22.5. 90 minus 67.5, angle POC will be 22.5. This is number 1. Okay, I'm pausing for a while. This is number 1. You know, in this type of question, the understanding of the question and the figure is very, very important. Okay, so please do understand the figure, and then it becomes very, very easy for you to solve it. Number 2, you have to prove angle BDC is equals to twice angle POC. Remember POC we have got 22.5, and if you multiply 22.5 into 2, POC was how much? POC was 22.5. If you multiply 22.5 into 2, you'll get 45 degree. So not a problem. The right hand side, 2 into POC, 2 into POC is 45 degree. Left hand side, see we are proving angle BDC equals to twice POC. Now the left hand side BDC, if you look at the figure, BDC, then this angle is always 45 degree, because this is 45, this is 45. The corner becomes 90. Okay, so this is 45 degree. BDC. So BDC 45, twice POC also 45. So left hand side is always equals to right hand side. So this is done. So we move to number 3. Number 3 is also very similar. We have to prove angle BOD or BOP. BOP, sorry. This is BOP. Okay. BOP. We have to prove that angle BOP is equal to twice angle COP. BOP. Let's see where is our BOP in the figure. Now BOP. 67.5. So left hand side is going to be 67.5. 3 angle COP. So write down 3 into COP. Now let's see what is a COP. COP. This whole is 90 degree. This whole is 90 degrees. So this is 22.5. So therefore 22.5 into 3, which is 67.5. So this is how we do question number 4. Now I'm keeping homework out here. Question number 5 and question number 6. You'll do it yourself. Now 5 and 6 will be your homework. Okay, so next question I am doing out here is question number 8. In question number 8, the ratio of the angles given to us, it's in the ratio 3:4:5:6. The angle of a quadrilaterals are in the ratio. Okay, the angles of the quadrilaterals are in the ratio of 3:4:5:6. So if the angles are given in the form of ratio, then if x is the common factor, then we can assume the angles are 3x, 4x, 5x, and 6x. Okay. If I add, should be equal to 360. It's a four-sided figure, polygon. So which is 18x equals to 360. So x equals to 20 degrees. So if you put the value for x accordingly, angle A, the first angle will be 3 into x, 3 into 20, 60, 4 into 20, 80, 5 into 20, 100, and 6 into 20 is 120 degree. The question out here is we should prove this quadrilateral, this four-sided figure is a trapezium. Okay. Now, if I draw the figure out here, someone like this, a four-sided figure, A is 60, B is 80, C is 100, and D is 120 degree. Now, we know that in a polygon, sum of the exterior angle at every vertex of a polygon, sum of interior and exterior should be equals to 180 degrees. So this is 60, so its exterior will be 120 degree. Now, if you also look at out here, this is 120 and this is 120. This is 120 and this is 120. Now, this happens only in case of alternate angles. And therefore, if these two are alternate angles, then this and this has to be parallel to each other. So, we know that trapezium means one pair of opposite side has to be parallel. So, therefore, as out here, AB parallel with DC or CD. Therefore, I can write ABCD is a trapezium. Right. So this is how we prove.